Training Solutions YouTube channel. My name is Ben Brook and today I'm going to take you through muscle structure and function. So with muscle function and structure we're looking at the sliding filament theory. So just here you can see the structure and function of the muscle fibre just here. Now when we're looking at the actual structure of a muscle fibre you can see that we break it down to the muscle fibre itself, which then breaks down further into the myofibril, which is the contractile part of the muscle contraction, and then you've got the myofilament. Now the myofilaments are small filament protein filaments that are known as myosin and actin. So I briefly said a comment about the sliding filament theory. So what is the sliding filament theory? Now, someone once said to me, how does a muscle contract? Well, I said, well, I look at my arm, the brain sends a signal and I just do that. Now for me, that answer was correct, but it wasn't scientific enough. And it made me a very average instructor. So I wanted to learn more. So I found out what the actual sliding filament theory was through education, through training, through doing courses like you're doing today, also through university. And the biggest thing with the sliding filament theory is, one, you need to know that it occurs within the sarcomere. Now the sarcomere is the unit of muscular contraction. So that's the important thing you need to remember. So that's one bit. How does the rest happen? Well, for a muscle contract, it requires calcium and ATP. ATP stands for, that's right, adenosine triphosphate. So there needs to be a chemical reaction within the body or within the brain that sends calcium ions and adenosine triphosphate, ATP, to the nervous, so the nervous stimulus causes the myosin heads, which is the protein filaments, to attach to the actin, which form what we call cross bridges. Myosin head will pivot and pull the actin towards the sarcomere, or towards the centre of the sarcomere, and this action will continue to happen so that we create a strong muscle contraction. It's a little bit like Velcro coming together, it's going to pull it together. So for example, if you take your bicep now and you squeeze it, it's not too bad, but if you really squeeze hard on that bicep, you'll feel the muscle get more contracted. Now, this process is repeated and the myosin heads attach further along the actin, which creates a stronger muscle contraction. Now, important things that you need to remember for like exam questions are stuff like, which is the thicker of the protein filaments? Well, the answer would be the myosin. The way I remember that is I think of it myosin and then actin, and I say it actin thin. So actin thin and then myosin. So myosin is the bigger one, actin thin or actin is the thinner protein filament. It's also important to remember stuff like cross bridges. Cross bridges are formed when the myosin heads attach to the actin. So remember that one as well. So when we're looking at muscle contraction, and in particular motor unit and recruitment, the strength of a muscle contraction will be affected by, number one, the frequency of nerve impulses coming into the muscle cell, and number two, the number of motor units activated itself. So those are important things to remember, especially when you're taking your exams. We're going to then look at muscle fibre types. So with muscle fibre types, we have two types. We have type 1 and type 2. They break down a little bit further, which I'll talk about in a second. So type 1 are our slow twitch fibres and type 2 are our fast twitch fibres. Now the first thing is, how do I remember that? Well, I have a simple method of remembering that. The first one is, when I look at a slow twitch fibre, it's slow oxidative fibres. It's red in colour and it contains a large number of mitochondria. So that's the powerhouse of a cell. And it's good for endurance type activities. Whereas the fast twitch fibre, type 2, is fast glycotic fibres. It's white in colour. It contains a low number of mitochondria and it's good for strength anaerobic type activities. So the way I remember it is I always think, it's something slow. We're looking at endurance based events. If you're endurance, it's going to be a aerobic activity, so you're going to need a large amount of batteries to sustain for a long period of time. Whereas if I was type 2 fast twitch fibres, it's going to be fast activating, which means I don't need as many mitochondria, I don't need as many batteries to power my cells because I'm only going for a short period of time. So it's going to be good for strength and anaerobic type activities. Now, I'm going to break it down further to you, unfortunately. So type 2 fibres have subdivisions. We have type 2A, which is fast oxidative glycotic fibres, and type 2B, which is fast glycotic or FG fibres. Again, working through muscle fibres, breaking it down further within some of your questions you'll have, we have fibre types. Now, fibre types, we have skeletal, smooth and cardiac muscle. So skeletal muscles are striated in appearance due to the sarcomere and the shortening to bring back muscle contraction. So they're shorter, they're the muscles that are on the outside of the body in our consciousness. Smooth muscles are found in the digestive, reproductive, respiratory and urinary tract. And then cardiac muscle is obviously found in our heart. There may be questions that you get in your exam papers, so please have a read through the manuals and check them out because it's going to really help you going forwards. Hope this has been of use to you today. This is video blog 4. Hopefully you'll join us soon. Take care and I'll see you soon.